Any minute now.
I think that's the minute, boss. Well, everybody, welcome aboard the SBAU Astro Hour. Once again, a weekly vlog and podcast. Vlog if you watch us, talking heads on the screen. Podcast if somehow you're listening to us. It's about astrophysics, telescopes, cutting-edge cosmology, and it's all for the South Coast Longtime Astronomy Club, SBAU, the Santa Barbara Astronomical Unit, and this is episode 127. God, it's almost going on 3 years here. For July 24th, a Monday morning, 11 a.m. every Monday we get together, 24th through the 30th. I'm somehow, I don't know how, but I'm vice president of the club. I'll introduce you to the rest of the gang here in a minute, host, and proud to say we're going to soon be into our third year, as I was just saying. Our support and benefactor is the beautiful Santa Barbara Museum of Natural History up in Mission Canyon, where we hold our meetings now because of post-pandemic surge and more popularity in that big auditorium known as Fleischman up there. You're invited. That'll be a week from Friday when Dr. Peter Love, friend of our president I'm about to introduce you to, will be talking about a year of incredible photographs and looking into the distant past and distance of the Webb telescope. Today, our night sky, complete with some planets, Jupiter's 4 main moons we're going to talk about. Even the great red spot's going to cross in front of us. You got the right scope. How about the Scorpion up in the sky? We're going to check on it. A new comet is passing by. You got to really zero in on it. 237/Linear. Now an Aquila, the eagle, Aquila, I guess. 2 contacts with asteroids. The DART collision on Dimorphos and the boulders that were sent into space. Man, this is good stuff. When we get back stuff from Bennu, which got picked up back in September. And finally, we explain those diffraction spikes on star images that I occasionally bring up. What in the world's going on? All in the lens, apparently. We lament the passing of a longtime member, Jim Williams, up in Lompoc, and we'll talk about him in a minute here with the people who knew him best. Let's introduce you to the gang. Man running the show is our president of 7 years or so. Ladies and gentlemen, meet Jerry Wilson. Jerry.
Good morning.
Thank you for taking over webmaster duty. His wife is the beautiful Pat Forgy, and he's 2 years older than I am. That's all I'm going to say. And here's in the same ballpark as Chuck McPartland, an incredible outreach coordinator, who is also married to a Pat. Pat is his our merchandise manager. Often makes me wonder whether you regret or cheer silently when you have to post those emails saying, we're canceling tonight, it's overcast. I got a feeling you go, thank God, Pat, getting laid in and relax for a change. And there's Bruce Murdoch, whose wife is Bonnie, and a longtime active member, also president of the Santa Barbara Theater Organ Society. And rather than asking you every week, Bruce, you just blurt it out. You tell me, hi, Baron, incidentally, we're having a big whatever organ recital this weekend in the Arlington or whatever. Fair enough?
Well, we normally have an open console on the second Saturday of the month from 9 until 11 a.m. Unless the theater has something that's paying them to be there.
Yeah.
And then we move it back or forward. And we don't get the date until like maybe a week before we can do it.
I don't know if I've asked you this, Bruce. Do you have a big organ in your house?
I have an electronic organ, a Con 640.
There you go. Do you play it?
Oh, yeah.
You know, the greatest organs.
Relaxations.
You know, can you guys guess the greatest organ scene in movies of all time? Captain Nemo on board.
I was going to say that.
Oh, Toccata and Fugue.
I can play that.
Unfortunately, it was about coming down on the Titanic and it imploded. Never mind. Let's go to quickly a story about.
I'm 5 years older than you are.
Did all 3 of you know Jim Williams very well?
I know him, but not real well.
I met him, and he was. Did he ever live here, Chuck? Or
he lived in Lompoc?
I know that, but did he come to meetings, or was it always
sometimes? Yeah.
And they are inviting members who knew him to come to, I think, this Sunday services at some church. Do you remember the church in Lompoc where they're having Jim's?
Oh, it's called something like Church of Christ, 138 North O Street.
Amazing, the memory of these guys. And we always start our show, this one here, numbered 127, 24th through the 30th of July, with some little lightweight, silly humor, science cartoons that are, or mostly science anyway, sent to us by our president. You might want to enlarge that just a little. Do I remember? Oh, instead of the Big Bang, here's what's coming out of it. The Big Sneeze, Society Allergists getting together, presenting their Origin of the Universe theory. God sneezed and we're part of it. We're just a little particle. Get your deity of choice. Welcome, press. There's the Earth right in the middle of all this. All right, here's what's described as a velociraptor, which equals a
Yeah.
distance raptor divided by a time raptor. It's a new formula or something old
No,
from.
it's just velocity equals distance over time.
Oh,
Yeah.
I see. All right. You got to check out those movies. Ah, here we have the incredible, what is that called? I got my notes here.
Excel.
Excel on the side of I guess a tomb in Egypt.
Yeah, it looks like hieroglyphs, Egyptian.
And does it look like Excel? Is that
Well, it's a
No,
square.
the characters are Roman numerals and the math is in Roman numerals.
Well, not quite, but yeah.
Whatever.
No V's or C's or X's, but
No,
oh,
They also
Taylor,
didn't have a zero.
I hope you sent that to Colin, Jerry. Here's a close-up of somebody in his office going, you know what? If my work helps just one person feel like this tiny little insignificant speck just lost in a cold, uncaring universe, then I'm doing my job, doggone it. We're also insignificant. And here's Hobbes without Calvin, or is this Calvin?
this is
without-
Calvin.
Calvin says, you know, okay, I've got the question here on my test. Explain Newton's first law of motion in your own words. Oh, okay. I love loopholes, he says. Those are my words.
That-
And here's a pumpkin weighing himself and says, hey, I weigh exactly 3.146295279. That goes on and on forever. Pounds. That's pumpkin pie. And here's Alexander Graham Bell at a very historic moment in history, finally testing it out. He says, hello, this is Alexander Graham Bell. I've just invented the telephone and this is my first call. Can you hear me? On the other end, yes, we've been trying to reach you about your car's extended warranty, Mr. Bell. Another moto call or what are they called?
Robocalls.
Robocall. And here's the bottom of those Ratatouille. Is that those
Rapa Nui.
Rapa Nui?
Yeah.
Easter Island, they found out they're pushing pushing
Even
around.
has a little cup holder.
Oh, are they connected to it? Why does it have a cup holder? And is there a significance to that? It is a supermarket.
It's just an
basket.
anachronism.
Oh, I see. Okay. They all have those. Oh, that's a tragic story, though, if you read that. What do we have here? Just fell asleep at the beach and I woke up with this hideous tan line. All right, gentlemen, you're going to want to explain that.
That's the
Tangent
tangent
function.
curve.
Yeah.
What?
Curve of the trigonometric function tangent.
Well, I knew that, of course. And there's a grid in there. And okay, somebody from either Gemini or Mercury's coming back in from orbit. And we're approaching atmospheric entry, Houston. All systems nominal. And a little thing flips out. Could be an antenna out of the side as it hits the heat. Houston, we're experiencing some oscillations. Vehicle is becoming difficult to control. And Houston radios back, Smith, retract that stupid arm. No, it's not ready yet. In retrospect, the re-entry marshmallow roasting or the toasting of the module was a big mistake. Couldn't get it back inside anyway, but boy, what a roasted marshmallow.
Okay.
This one you're gonna have to enlarge.
No, that's where we started.
Oh, that's a restart. There was one that I couldn't even read because it was a big long strip up and down. What are your
Oh, yeah. I'm not, that was more recent. I didn't get it in this batch. You'll see that next week.
All right, well, somewhere in your files, Jerry, is that great one where the dog is inside the dryer, locked in, looking out the little window, and the cat's sitting there. And Maureen's joining us. Who would that be? Oh, that's got to
It's
be
Tom Whittemore.
Tom Whittemore.
Hi, guys.
Hi, Tom. Those last minute moments on the throne are just obvious and wonderful, aren't they?
Well, if that were true,
Well, it was a great newsletter. There's some stuff in there. Let's see. We got a great bunch of stuff happening soon, Chuck. The next few nights, you're going to be setting up every night for several days in a row. But
Yeah, it's like 5 days in a row.
okay, where? Can you run them down real fast?
Tuesday is Camino Real Marketplace. Wednesday is Carpinteria State Beach. Thursday is Bacara Hotel. Friday is Refugio State Beach, and Saturday is Kachuma Lake.
Yeah, then I'll see you Thursday, Chuck.
Great.
Fantastic. I'm going to start.
We're gonna have dueling 8-inchers, Chuck.
You and Tim, huh?
Someday I may break down and buy one of the telescopes that are out there in the shed at the museum. In the meantime, you're all invited, and we're going to have Dr. Love do a great report on the Webb telescope in 2 Fridays from now at the museum. What are we looking at here in the night sky?
Ron, you're welcome to use those telescopes in the shed. Tom Totten will show you how to use them.
Well, that's a whole course I'd take at City College to
No,
set up one of those things. Don't think I could, especially you're in the dark. You want it dark too. You got red lights on out there.
That's so people can see things in the dark and don't trip over them.
Well,
And don't blind the people that they're coming up on.
Yeah. Hey, Chuck, how did we do Friday night? That was a nice outreach.
Friday was 70, I think. Let me look.
70, okay.
Yeah.
Okay. Music Academy students kind of filled it. It was neat.
78 customers.
Nice. Okay.
and
That's good outreach.
How many did we have in last month's Star Party?
370.
Well, that's not bad. And the number of chairs inside Flashman is about that many, isn't it? 300 or so?
I think they can fill it with that many. Yeah.
Nice.
We get about half full these days, right?
About that.
Or half empty.
I was gonna say the same thing.
The night sky, west. Is this looking west, Jerry?
What's that? Oh, yeah, this is looking southeast. See all the little things down here, southeast, east, southeast. So this is tomorrow night, 11 p.m. Be almost the same tonight at 11 p.m. So the attention focus is here. There's a lot of good stuff here. This is a good time of the year. If the sky is clear, we're in fogland out here. Foglita. There's a Pluto and M75, nice cluster out here. So this is a fairly faint object. It will take a bigger scope for you to pull that in and see it. But if you have something 10 or 14 inch, which is stuff that size is in the shed. I think there's an 11 or 12 inch Dob in there. So
actually, it's a 14-inch Dob and an 11-inch Celestron and a couple of 12-inch Meads.
Yeah, the 14 has a Zambuto mirror, Jerry. It's pretty good.
Okay.
Not this 14.
Not this one?
No,
Okay.
that was the 12 or 11 and 12 that we, I think, sold.
Oh.
A Dob is short for Dobbin?
Dobsonian.
Oh,
Dobsonian. Okay.
Dobson,
Dobson. Oh, okay.
that's his last name.
Okay.
Right.
You know, incidentally, just for your information, it looks like I've got 3 guys that aren't on our board that are going to talk in December about different incredible topics.
Okay, excellent.
I could just fill September. I got Bob Berman from Astronomy Magazine talking to us in October. We got that straightened out with the museum. All right, here we go. What do we got? Some M.
So anyway, earlier than 11 o'clock, these will be higher up. These are heading.
No,
this is,
they'll be lower.
Yeah, this is east. They're rising.
Yeah.
So later in the evening, they will be higher up. And let's see where we
Just
go.
above, just above that backward horizon that goes the wrong direction. Inside dwarf planet Pluto. Oh yeah, I should have said that as a plug too. I meant to. How do they know what's inside Pluto? It's not even a full planet anymore.
As the spacecraft went by, they could measure the gravity.
Okay, does it have a field?
Sure.
Gravity
Well, everything,
field?
everything
Yes.
is massive.
Everything does.
Well, I'm not a gravitational, an electrical is what I meant.
Oh,
I think
electrical.
it probably has some very weak magnetic and electric fields, but those do not dominate its behavior. The key thing about this, and as Chuck said, when the spacecraft goes by, it feels the gravity. And the gravity, these things are not completely uniform usually. So variations in your orbit can indicate clumps of higher gravity. What do they call them? Gravcons or something?
Yeah,
the moon and the Earth have some. I don't know about Pluto. This was a very interesting diagram I happened on. It indicates that Pluto is probably surrounded by a mantle of ice. See the core in there. It's a rocky core. So this is probably the size of Pluto here. And then the rest is methane and nitrogen frost coating its surface in here. This stuff, it's not real clear to me what they're labeling in that, but I know that when the Pluto is an elliptical orbit, and when it's closer to the sun, a lot of this material, which is still very far away, a lot of this material thaws and evaporates and makes mostly nitrogen and methane atmosphere around the planet. And when the planet is far away in its orbit, this stuff freezes down and you get the surface features that, what was the name of the
heart?
Combo Regio.
New Horizons.
Oh,
New Horizons saw the surface features and photographed them.
that's the probe. So you're saying that little ping pong ball in the middle is the real Pluto and the rest of it is
That's the rocky core.
Oh,
So everything else appears to be made out of ice, which is like a rock up there. When they landed something on Titan, there were boulders all over the place. Those boulders are believed to be boulders of water ice or carbon dioxide ice. So at low temperatures, these things are very solid.
Why don't those sublimate and over time disappear?
They probably do.
There's not much energy input from the sun at that distance. So
Yeah.
would it be safe to say that every element or compound of elements can be in a plasma form except for water?
No, water can
plasma, you don't have molecules, that's for sure.
Right.
Yeah.
That's the
Water
first
is
state of matter. You get stuff
Water
hot
is-
enough, it becomes a plasma.
Okay.
Water loses its waterness when it comes apart.
Well, I just
No
know that.
longer wet.
Okay, got it.
So in one way of thinking about this, if Pluto were to head into the sun, come inside the orbit of Jupiter or something, it would make one hell of a comet
Yeah.
with all this hydrogen and frozen material on there.
Is
The
it still
gravity-
outside the orbit of Neptune, Chuck?
Yes.
Okay.
And will be for quite a while.
Yeah. Okay.
What are the odds they might meet someday?
No,
They're
they're in
not likely.
synchrony.
Oh, okay. I don't think any of us have outlived one complete Pluto orbit, have we?
I don't think so.
Not yet.
248 years, it's tough.
Okay, well, we're getting close. Wow. Dwarf
But it's
planet
been
Pluto.
almost 100 years, since it was discovered.
Well, I think we're keeping this little disgraced planet alive, even though it's a dwarf now.
Well, the joke was, when they first found it, the calculations, which were in error, so it was kind of a lucky happenstance that they found it. They thought it was 10 times the mass of the Earth. So it's like, oh man, obviously a major planet.
Yeah.
Really?
As they took more and more looks at it, they said, well, this thing's really small. And the joke was it was gonna, each time they looked at it, they said it's small. The joke was it was going to evaporate in 70 years. Somebody did a graph, and that's about how long it took. So,
Yeah.
Well, do we only have 2 official dwarf planets?
no, there's 5.
There are 5.
Yeah.
If we get 2 more, we could all give them new names, couldn't we? With Snow White, and because there's a
7.
Yeah.
there's a dearth of good astronomical names for new bodies being discovered. So why not rename it, Dumbo or
Yeah.
whatever?
And Ron, it didn't take a huge telescope for Clyde Tombaugh to see that thing. So he used a refractor, right, Chuck, and Flagstaff?
It was a 13-inch astrograph.
Yeah. Okay. So that's not a big scope, but
Yeah.
when you take pictures, you can see a lot.
But
Yeah, he did it on film.
Yeah.
I think so, yeah, because he watched the thing move. with respect to the background stars.
Yeah, he did a flip comparison with the images from night to night.
But inside the asteroid belt, which is between Mars and Jupiter, there is a dwarf planet that's a little bigger than a normal asteroid. And is it built like this one we're watching here, right here? Are they pretty much the same, you think?
They're similar. It's water ice.
Yeah.
Okay.
And the name of that is Ceres.
Yeah.
Yes.
What did I call it? Oh, I didn't.
No,
hear
you didn't name it.
Wonder where the other three are. Are they out?
Anyway, right next to that,
Well,
at
the
this
other
date,
three are Maki Maki, Haumea, and Iris.
Out in Kuiper Belt? Okay. And where are we now, Jerry?
this is right next to right here, there's Pluto, and right there's M75. And this is a Hubble picture of M75. I believe it's a Hubble. But it's very interesting. This galaxy has a or not galaxy. This globular has a very tight core. It's hard to resolve. And it has a lot of red giants populated around here. And one blue giant.
So rather than light years apart, they're light months, light weeks. They're
I think
orbiting
on the order of light weeks.
Yeah.
light weeks. My God. You'd never be able to sleep on a planet orbiting one of those stars, would you?
Not too many astronomers.
But it is a nice object to find.
Yeah.
Okay.
Now
No
this,
variables, no variables this week, but lots of
Yeah.
star clusters. Where are we now? Oh, the comet.
yeah, the
Linear.
comet linear is right in this region. And let's back up a little bit so we can see what the region is. So it's in the Eagle, Aquila. The
Right.
characteristic stars that are easy to pick out in the sky by naked eye is Altair.
Ah,
And it's companion to making a little distorted line.
Mhm.
And this up here is, whoops, NGC 6760, which is another globular cluster. Another very nice thing. My planetarium software doesn't recognize it, so I had to mark it manually.
Mhm.
But comet linear is fairly faint around 13th magnitude. It will need a bigger scope to see it. So
will it get brighter?
it's not terribly, no, magnitude 13 is way past naked eye visibility.
Well, I know that, but is it headed our way or headed away, or is it just totally on the other side of the solar system from us?
It's in orbit around our sun.
Well, I know that, but usually they get brighter. They come and they go.
It is approaching us, and it should get brighter.
Ah,
And people, we just stay away from that, because if something's coming in, it seems everybody goes toward it's going to be the brightest comet since we were hit by an asteroid. So, but almost none of them pan out.
well, can any of you gentlemen remember the names of those other comets in the months past we've been talking about that are come and gone, or maybe still out there and we're not talking about?
It was another
Neowise was the last really
Yeah.
nice.
Yeah, that was a nice one.
Hmm.
It was kind of 2019, Chuck.
Yeah, yeah.
Yeah. Late in the year, if I remember right.
And the big theory behind them is that some star passed by the Oort cloud or Kuiper belt and kicked them out of orbit and into the middle, and they go back out again. That's pretty much why.
Yeah, they interact with each other too, although they're,
Yeah.
So
Oh,
I'd like to
right.
give Tim Crawford a kudo. On Friday night, he gave me second light on his scope. It's a beautiful telescope he built. And I said, hey, can you get the wild ducks? He got it. And it did look like a V. It was really nice. You can see the M11 sitting out there on the right in Jerry's diagram.
Yeah.
He got a number of things too. He's a great star hopper. Tim's really good star hopper.
Yeah.
He's not joining in on text today because he's taking his cat Bamboo to the vet.
Okay.
Well, that's a
Hope
cheap
he's okay.
cat,
Yeah.
must have demanded it. We know about cats, don't we? Now, where are we in space? Gotta
This
be
looks
in
like
large.
M6 and M7 or
Yes, there are two open clusters.
Huh.
Well, that's a wide field, Jerry.
Yeah,
So open clusters might be defined as clusters that aren't terribly crowded and bright.
Young stars.
Done.
yeah,
Yeah.
they're fundamentally different than, have different origins and different life paths than globular clusters.
Are they usually sitting there inside giant clouds and nebulae?
That's
Once
where
they
they
were.
form. They used to be called galactic clusters because they're along the plane of the galaxy, which is where all the new star making material is.
Gotcha.
So this is M6
Mhm.
and this is M7, looser. This is called
Butterfly up
M6.
top.
Yeah, the butterfly cluster, and you can kind of see it's got two wings there.
Yeah.
I'll be damned.
The other one sometimes called Ptolemy's cluster.
That's right. Because Ptolemy noted it around AD 130. He mentioned it. These are both naked eye objects.
Mhm.
If you know where to look and you have a dark sky.
Yeah. The stinger stars in Scorpius basically point pretty close to
Mhm.
Ptolemy's cluster, the lower one.
So that's,
It's a nice binocular object too. Both
Yeah,
of these.
these are features in Scorpius, the scorpion.
Mhm.
you say naked eye, that's how Messier got him. He did use a telescope.
He did. He used a telescope and he used letters from friends.
And the ones he missed, somebody came up with them for NGC numbers, right?
Sort of, yeah. They were
Yeah.
different.
Yeah,
There
he
was a
bombed a
different
lot
thing.
of them with
There are
machine.
a couple of puzzling things that he missed. For example, he missed the third galaxy in the Leo triplet. He
And
got
the
the
double
first two.
cluster.
The double
Yeah, he
cluster.
missed the double
Thing.
cluster.
Missing the double cluster, my gosh.
Well, and these he sort of stuck in later, even though they're M6 and M7. They weren't. I don't think he really mistook them for a comet in his telescope, but he started to pad his list to try to get elected to the French Academy of Sciences.
Is that right?
I heard
And
it worked. Yeah.
Yeah.
Well, do you suppose in 5 centuries that astronomy has existed, anything up there in space has changed? Has there been a star move a degree or a
Sure,
minute
Oh,
or
yeah. Mhm.
really?
Yeah,
sure. Even
Piazzi's flying,
Hipparchus.
I'll be
Piazzi's
damned.
flying stars one.
Yeah, even Hipparchus noticed that changes mainly due to the Earth's changes in its orientation. But
Mhm.
Well, I remember my grandpa 70 years ago pointing to what he called the Three Sisters, Orion's belt, and it's still the same today.
those are really far away, so you're not going to
Mhm.
see much motion in those.
Ah, so the close-up ones are moving fast. Okay, got it. That makes sense. Wow. Okay, what are we going to say about these two M's? Nothing. We're going to go to
They're
the
nice to look at.
Yeah.
They're great outreach targets.
Yeah.
Okay.
So this is the evening sky in the west. Early evening.
Yeah.
It shows, and this would be about 9 o'clock, so about an hour after dusk is over. Still some faint stuff there. Mercury is coming up in the evening. It used to be in the morning, short while ago, last month.
And Jerry, I saw it Friday night. It was kind of going in and out of the cloud bank, but it's
Okay.
it's going to peak around the 7th of August, I think. So it's coming up.
Okay.
And Venus is racing down.
Yeah.
Do you suppose we can get anything this detailed and clear inside the new planetarium with
The new projector.
Yeah.
Look, show this sort of stuff right now?
Yeah. Oh, yeah.
Can't wait. I haven't seen it.
Yeah.
Huh.
We'll be able to do that in 2 Fridays, right? At 7 o'clock.
Yeah.
Yeah.
4th of August.
Yeah, Chuck and I recruited a couple of folks at a little dinner party last night to come and look at the new projector with you. You know, are you
Okay.
going to be running it, Chuck? Probably you.
I did on Sunday. I did yesterday, but next Sunday is Jim's memorial service, so I'm not going to be doing shows Sunday.
But on the 4th, you know, you give that.
Oh,
7
that'll be. I'm sure I think we should have Chrissy or John run that.
Okay.
Chrissy's probably most familiar with it.
Okay.
It's really nice.
Mhm.
Is she teaching a class today?
Well, school is out. She teaches
Yeah.
music in elementary school.
Oh, that's right. It is summer. Okay. Well, I'm looking forward to it, gentlemen. Wow.
Okay, this is one of our last looks at the Virgo cluster. There's a very large open cluster up here called Melody 3 or Melody 111. So it took me a while to decide if those were Roman numerals or the number 100.
And that's
One-
basically Coma Berenices.
Yeah,
Yeah, right there.
yeah, there's a lot of Malad objects.
A lot of stuff up there. The Black Eye Galaxy has a big dust cloud in it. It gives it a name. Here is the dwarf planet Ceres over here in Virgo. Here is the almost a dwarf planet, 2 Palles, the second one after Ceres. Mars, Mercury. So Venus has set. And Bode's Nebula, M81, M82. A lot of stuff in the sky this week.
Yeah.
Let me ask about Ceres. If you're tracking its orbit, it's slower than Mars, but faster than Jupiter.
Yeah.
And in the same plane, perhaps?
The ecliptic.
It's pretty much, in the main asteroid belt.
Yeah.
Well, I'll be darned. But those other 3, you say there's 5, and the other 3 are out there in the Kuiper belt. They're not asteroids, right?
That's
The other
correct.
3. Okay. Dwarf planets. Can see Grumpy,
There was a
Dopey.
exoplanet system. I think it's the TRAPPIST
Goofy and
system
Ron.
that has 9 planets in it that are all about Earth size.
It's 7,
And
I
there was
think.
a suggestion
7.
that they name the first 7 as after the dwarves.
Oh, I did.
That's
yeah,
that Trappist group, right?
Yeah,
Yeah.
the TRAPPIST 7 planets. When we went to Belgium just after that had been discovered, the name TRAPPIST comes from its transiting planet system or whatever, but they deliberately made that acronym into TRAPPIST because it was a bunch of Belgian astronomers and they liked Belgian beer that's brewed by the
Yeah.
Trappist monks. And in the airport in Brussels, they had a big banner that said, our astronomers discovered a planetary system and they named it TRAPPIST because of our beer.
yeah.
Probably a triple for Matt too.
Okay, well, we're going to zoom in a little bit, take a look at Melody 111 and M85 right here in the Virgo cluster. But first, we're going to look at Venus, which had set by that picture. But this is the projection for this month. By July 31st, Venus is going to be a very thin crescent, going to be 20.3 degrees from the sun, 5% illuminated. It's going to be quite big, 53 arc seconds. That's around the size that Jupiter gets at its biggest. It is in the 50 arc seconds. So right now, what are we, 24? So we're about in here. It's very dramatic if you can catch it in dusk. And in taking pictures and looking at it in dusk, as long as you avoid the sun, very important, the sky is a little brighter. And so the contrast is lower. And so it doesn't glare your eye. You actually see more detail in the shape of, and a crisper look to the planet.
And it's quite obvious, even in binoculars now, that it has a crescent shape.
Yes.
Yeah.
But to the rest of us, it's a little bright pinpoint on the horizon, isn't it?
Okay, this is M85. It's a lenticular galaxy right on the edge of the Virgo cluster.
Wow.
There's a number of galaxies there, and looks like there, a couple of things way in the background. But it's a largely featureless structure. And the open cluster Melody 111.
Actually, Jerry, that's a picture of the beehive.
Is it?
Yeah.
Yeah, a lot of triangles.
I was wondering about that.
And if this were Jeopardy, you'd have to form that as a question instead of an answer. But man, oh man, you suppose all those stars are orbiting each other as like a multiple binary, trinary, quadrary
Well, they're all gravitationally bound.
Okay, this is Melati
Loosely.
111, which is shaped like a scripted S.
Oh, okay.
It's actually a very large cluster, but it's a faint cluster.
All kinds of letters up there in the heavens.
Well, it's
Melodic.
not naked eye visible.
Yes,
I
it
thought
is.
Melania-
It
I
is,
thought
yeah.
Melania is with an E. Doesn't it?
Yeah.
Okay.
Yeah.
Okay.
TTE.
Yeah, because she's making it look like it's an Italian guy.
Huh.
There's a lot of Italians in astronomy. Okay,
Huh.
Jupiter, here we go.
Okay, now this is looking at the king of planets here. This is
You can enlarge that. There we go.
okay, now it's a long thing like this to show Callisto out here. Io, Ganymede, and Europa. Io is just at this time, which is around 4 a.m. on the 26th, Wednesday. The Io is just about to go behind the disk of Jupiter, and Ganymede is about to cross the disk of Jupiter here in transit. And you can see very closely the great red spot is in transit right on the disk, and there's a close-up of that. So that's the same shot, but just closer up.
I see Jupiter come up around 1 in the morning here, just coming up over the hills.
Yeah, it's about right. And so this is Io just before it goes behind, and Ganymede just before it goes across. And it's a good time to look at the great red spot. Now, if you look at the great red spot, I think the James Webb Scope has looked at that. And it looks like there's two great red spots. There's this one, and then there's another one around in here that shows up in the infrared, almost as big.
Well, for a while, a couple of years ago, there were three in that general vicinity.
Uh-huh.
They were calling them the Great Red Spot, the Great Red Spot Junior, and the Not So Great Red Spot. And the Great Red Spot kind of gobbled one of them up, and the other kind of faded away. But that may be remnants of it.
Well, it's similar to the many hurricanes or tropical
Yep.
storms we sometimes get on our planet at the same time. Look at that.
It's also
I'm not
quite
too
red.
sure what the great red spot really is. These are all storms. But is this storm, because it's so persistent, is there a surface feature down below or something that keeps it going?
Well, it couldn't be a sunspot because it's not the sun and it's totally different logistics. But
No, magnetic field doesn't support that.
why do you suppose they missed all those other two or that other one all these years?
Well, you
What-
miss it here too. It's in the infrared. Nobody had done a study in out of visible bands.
And these storms come and go on Jupiter. The
Yeah.
Great Red Spot is and the three white ovals that you see down below it and to the right. Those are the most persistent, but they do come and go.
Yeah.
And
the
there's
Great
even a
Red
guy
Spot-
up at Berkeley that's predicting that the Great Red Spot's going to go away.
Well,
Sometime
they
in the
predicted
future.
that several years ago too, when it started to fade.
Yeah.
Yeah,
And now it's come back a bit.
yeah.
Yeah.
But when I was starting in astronomy, it was much redder than this.
Well, that was back when I think Galileo first saw it, didn't he?
He
Yeah.
did not.
He was
400 years
just
ago.
down the street.
No, Galileo didn't see it.
No.
Oh, he didn't. Well, who was
No.
the first? It's been 300 years, they say at least. It's been
Yeah.
raging on the surface of
Whoops.
Jupiter. And little Io, is it closer to the surface of Jupiter than our moon is to us, you suppose?
No, it's
Good question.
I think about the same distance.
Because it's wrenched with tightness and whatever that's called, fluid dynamics it makes for the volcanism.
Tidal interactions with the bigger moons, not so much with Jupiter, although that contributes.
Really? Well, it looked like Callisto was way out there and
Yeah, Ganymede's doing most of the pushing and pulling. Ganymede's bigger than the planet Mercury.
but what we're seeing right now, it looks like it's just right above the horizon. It goes out further than that. Are we seeing it disappear behind the planet? or-
Yes, yes. Uh-huh.
Okay,
Yeah,
got it.
it's in the background.
I just got a note here that says my internet connection is unstable. If I disappear, carry on without me and I'll try
Oh,
and be
no,
back.
we need you.
So
President.
if you have a large telescope, say 12 and a half inches or larger, you can, and your seeing is very good, you can actually see surface features on Ganymede.
Really?
Yeah.
That's not one of the destinations in the future, is it, of any NASA probes, as far as I
Uh,
know?
well, I think the icy moon orbiters are gonna go out there and look at that,
I'll just look at it.
Yeah.
various ones.
But it's Europa and what's the is that the ice one?
Yeah,
Yeah.
Oh,
and so is Ganymede and so is Callisto.
they're all on.
Ganymede and Europa are differentiated, so they have a core and they have liquid saltwater oceans, but Callisto seems to be never differentiated. So it's just an amalgamation of rock and ice that's all thoroughly mixed.
Okay.
All righty, what is this?
This is the, what is it?
Dimorphos.
Dimorphos. Thank you.
Oh,
This is the one we hit with our impactor. And this
Dart.
is a trail.
yeah.
Yeah, dart. This is a trail of crap that was thrown off. It's got a tail now. And these are boulders from the surface.
Oh,
This one is identifying all of the boulders that are off there. The belief is that the boulders that were seen and the impactor just before it impacted are these boulders that blew off the surface.
Yeah, and Ron, as a collection, they're also known as Boulder Dash.
Boulder Dash. But it looks like a comet. I'm sorry, what's the big streak?
That's a tail of dust.
That's little rocks.
Oh,
and particles of dust. Now, if this comet were heading straight for Earth and we hit it and blew it off its path, these things would still be flying in formation with it, and these might hit us. So depending on how big it is, there might be the shotgun blast of particles. So one of the things they're studying is the efficacy of hitting asteroids, trying to move them off their path when they dissociate real easy. And you don't want, it's almost as bad to be hit by a shotgun blast of all the particles if you blow it apart as it is to be hit with them all at once.
or we'll have an incredible meteor shower.
Yeah, that
We
too.
would. Then, so the idea is that if you get a really hard object like Campo Cielo meteor, big thing like that, that's made out of iron, hitting it will move it offside with minimal scattering of particles. But if you hit a rubble pile like Dimorphos, then you could be creating a bigger problem. So one of the astronauts had suggested about 20 years ago or so that we use a gravity tractor to pull the asteroid off path. And that is, we park a massive spacecraft next to the object to fly in formation with it. The two will attract each other with their mutual gravitational attraction, but you keep firing rockets to keep your projectile moving away from the satellite or to the asteroid, and that'll pull the asteroid eventually out of its path. You need months and months, maybe years of working on it to see the effect you want.
Sounds like you're quoting Arthur C. Clarke from one of his books.
And this impact ended up being much more efficient at changing the orbit than they expected.
Yeah, way out of the error bars they predicted. By the way, Jim Williams was personal friends with Arthur C.
Yeah,
Clarke.
I was just about to mention that too, Jerry.
Yeah.
I know he visited him a couple of times in Sri Lanka.
Yeah.
Wow. And we know who he was friends with, Director of the Year and back in '68. What's his name? Kubrick. Yeah.
Oh yeah.
We had to have hit this thing, Jerry, with something really big, not little like the Huygens probe.
This was really small that we hit it with. It was like the size of a refrigerator.
Yeah, it was like the Huygens probe. The Huygens probe, I think, was 800 pounds of pure copper or something like that.
No. The Huygens probe actually had instruments on it from the European Space Agency. You're thinking of Deep Impact, which hit that comet. That was a copper cube, basically.
Okay.
That wasn't the one that was supposed to go through the tail and scoop up stuff and bring it back to Japan.
That was a different mission. Yeah.
But something
Speaking of which,
something the size of a refrigerator sends out big boulders, bigger than refrigerators, dozens?
Well, it's going tens of thousands of miles an hour when it hits.
Oh, yeah, there it is. Look at, that's what it looks like. Wow.
Well, no, this is different.
Oh, this isn't it?
This is
No.
Osiris Rex.
Oh, that's the one coming back from Bennu.
Yeah.
Yeah.
Okay.
So on September 24th of this year, it picked up little rocks from Bennu. Couldn't find any refrigerator-sized rocks. So it's coming back. It's going to land at the Department of Defense's Utah Test and Training Range
Whoa.
up near the Dugway Proving Ground where they killed all those sheep 50 years ago. But anyway, inside joke. So this is an artist rendering of the spacecraft. I don't know whether that's
That's a sample return arm. And
okay.
that little saucer at the bottom is about the size of a dinner plate. And it had a nitrogen bottle there of pressurized nitrogen, and they figured they would use that to blow samples up into the collector.
Yeah.
And when they hit the surface, they didn't realize how almost fluid-like it was. And they blew this nitrogen thing. They made a crater 30 feet across on Bennu, and they got like kilograms of sample when they expected only grams. They even had trouble closing the collector because there was so
I
much
remember
stuff
that.
jammed into it.
And then the two square flat flip arms, those are solar panels, right?
Most
Yeah.
likely.
And how in the world did it blast off or just bounce off to come back to us?
It when it sensed that the dinner plate was touching, then it fired retro rockets to retreat.
And it's got a computer on board that's pre-programmed to get us right to that Utah landing site. Amazing.
Yeah.
They do have software on board. They have a computer on board. These computers are frequently programmable in case you decided you made a mistake or you want to do something different. You can send up new programs to accomplish new tasks.
Well, do you suppose they're trying to keep what's coming back, whatever minerals and rocks, totally in an isolated vacuum? So
I think that's the idea.
and they got to work on them in a vacuum then.
Yeah.
Wow.
Well, no, not once they get them here, but they want to.
Yeah.
They don't want to spread whatever's there all over the place, you know.
And they don't want us to contaminate the
Yeah,
samples they
right.
get back. So this is Bennu. This is
There it
the
is.
asteroid that it landed on and scooped up some stuff. There are a lot of boulders here.
Looks like a large chiclet.
I would throw that chiclet away and look for another one.
A huge chiclet, yeah, right.
Somewhere I have a video of their grabbing the rocks
Oh,
and
man.
the
Well,
but I'm not finding it right away, so never mind.
Okay.
is this the front end of it only that's coming back? Because the rest
This
of
is
the
this is
spacecraft.
the sample pod. And this is a practice round. They've run through this several times to practice getting it. So
Squared off refrigerator metal part behind this would burn up on the way back in.
do you people see little red arrows here and here?
Yeah.
Yeah. Mhm.
I wonder what those are from. Anyway,
Crucial marks.
well, usually they indicate supernova, but today it's not. And this is the laboratory situation at Lockheed where they're going to open and this is the sample thing they had the other day. They're practicing opening it under clean conditions.
Ah,
Now, these rooms are rated, and this is probably a class 10,000 room, where it means that there are less than 10,000 particles per cubic something or other.
Meter.
the dreaded clean rooms.
I found my video. You want to see this thing collect the
Yeah,
rocks?
go ahead.
Okay, I'm going to ask to share screen.
Go ahead.
Okay,
Oh,
here we go.
this is Bennu.
This is
Yeah.
Bennu.
Whoa.
Okay, things got really exciting there for a sec.
Yeah. So that's it.
Okay, thank you.
Wow, and boulders got kicked out.
Well, no. This was the sample return for Bennu, so not boulders, just
I
Yeah.
see, that's right, that's
rocks.
was the other one that we crashed into
Mhm.
that was going like a lickety split, okay. So a clean room is just a cleaner air, it's certainly not vacuum, or those guys wouldn't be able to stand there.
Well, those arrows went away.
Ah,
I guess the probe blew them away.
Yeah.
Now, this is just a quick picture that I saw and I put in here. Wasn't highlighted or anything. But this shows an amateur took this from, oh God, I forget where. Jordan, I think.
okay,
From Irbid, Jordan. And it looks at a nova, not a supernova, but a nova. You can see that usually if it was a supernova, there'd be a galaxy around here that it would be in. But this is one of the stars in our galaxy, and it's a nova. And if you want, you can, what is it? Somewhere around here is oh, there it is. Right ascension and declination. So it's in the south below the equator. It's magnitude 12.4 visual. So it's fairly faint. You're going to need something about an 8 or 10 inch telescope to at least have a chance of glimpsing it.
but a nova, it's a
It's a nova. It's not a supernova.
Oh, just an exploding star.
This
that's
is an
so-
ordinary house nova.
Yeah, it's an explosion, but not enough to destroy the star.
Right.
Oh. So it'll fall back on itself? Is that what happens?
Well, it's usually a binary system where one's sucking material off the other, and then the stuff detonates, but not at a level to destroy the star.
Well, there's got to be a line drawn between binary and orbiting, because your two asteroids, for example, the one that Dart hit, that was it bigger or smaller? It had to be smaller than the one that's orbiting, but if they're both orbiting about the same, they're a binary system, aren't they?
Well, there's still a binary, even if one's small and one's big, but yeah.
Where do they draw the line, and something becomes an orbiting moon?
Well, two things that orbit each other are a binary,
Yeah.
and three
Okay.
things are a trinary.
So
yeah.
we and our moon are a binary system.
That's correct.
Yes.
Oh, well, I've
And the Earth and the Moon orbit a common center of gravity.
got it.
And
Now-
moon is just, binary is a sort of generic term, and then moon is if it's, it's significantly smaller than the parent body.
All right, Whittemore, you knew that. Murdoch, you knew that, right?
Of course.
Okay, of course, I'm the odd man out here. The dreaded diffraction spikes. Why in the world do we live with those?
They look
The
really
laws of
cool.
physics.
It's like a Christmas tree.
Shows
out
the
there.
wave nature of light.
Yeah. Well, all right.
Now, my first telescope had a primary mirror, a secondary mirror, and one spike strut, just like this.
Mhm.
And that's what Edmund Scientific handed out as a kit with the eyepiece focuser and stuff.
Mhm.
And I had spikes like this. If you you can't, if you have spikes on both sides or support on both sides, you get a more pronounced pattern. The common one today in most scopes and my Newtonians have this kind of cross pattern. And you have these kind of diffraction spikes around every point object. At one star party, CalStar, I saw a guy that had put fishing wire over the front of his refractor so that he would have star-like diffraction patterns around it because he thought they looked cool.
Yeah.
And that's kind of what you see with Hubble pictures.
How about
Is
the
that-
web? Does it get
No,
them?
no, the web is the one below that. It was with
Yeah.
the 6 spikes.
Yeah, these are introductions.
Yeah.
So you see, if you have 3, you get 6 points. Or rather, 3 long ones or 6 short radial spikes. And the James Webb has a primary mirror shaped like this. And it has struts like this. So this system gives diffraction patterns like this. And the diffraction pattern of the mirror, because of its facetedness, its 6-sided features, it's also got 6 features like this. They're at different angles. And this is the final diffraction pattern, and you can see this. It's a characteristic of James Webb. No other telescope produces this pattern. Unless you leave the Bahtinov mask on your telescope when you take pictures, then it looks very much like this.
Well, are there scientists or astronomers that say doesn't give me a true picture of the star or the body, that trying to correct this by any chance? Get rid of
Well,
it?
that's as true a picture as you can get with
Yeah.
that kind of structure.
Yeah, it looks pretty cool, I think, and they don't bother to take that out. But if you're really interested, there is a deconvolution routine. There's a number of them, and you put in what your telescope is, the type and all the details about it, and then it will take out the diffraction pattern.
It will. Oh.
It will do a good job of it. It's not perfect, but there's no point to do it. I mean, if you want that, use a refractor, because the stuff looks cool.
Now, if you're looking for faint double stars and measuring their position with a Newtonian, like the upper right picture with the cross diffraction pattern, sometimes you have to kind of rotate the telescope so that the diffraction spike doesn't cover up the faint companion.
Oh, okay.
So you would move your telescope and rotate it so that the object you wanted to look at in detail would be right here where the arrow is, where the cursor is. So
Schmidt-Cassegrain shouldn't have diffraction spikes because they don't have the vanes to hold the mirror.
Who what?
The Schmidt-Cassegrain does not have vanes to hold the secondary mirror.
That's right.
So you shouldn't get diffraction spikes.
Right.
The
There are people who have
central-
veins. Oh, go ahead, Bruce.
the
ahead,
central thing does have its own diffraction pattern, but it
Yes,
spreads
right,
the
but
diffraction out through the whole field of view and lowers contrast everywhere. It's not in spikes.
right.
And also, some people have veins for holding the secondary here that come in like a spiral instead of being straight.
Yes.
Right.
They will
Yeah.
also spread the diffraction pattern out into the whole image so that you
Right.
don't see it.
Right, it's kind of like, Chuck, it's kind of like a little, a cone-like structure that holds the secondary against the tube,
Yeah.
you know, yeah.
And there's no.
I've seen a couple of scopes, made by amateurs that have that feature. Okay, but most of them are the kind I build, and Tim builds, and Jerry probably are up there in the upper right.
Yeah.
Well, do you suppose telescopes of the future will have some sort of program or item or device to eliminate them?
No, it's not worth it.
There's no reason to eliminate them. They look cool.
Yeah.
But there's eventually there are building different types of instruments and telescopes for outer space use. And these will be large mirrors of some type. And the secondary or the camera will be floating in formation with them. There won't be any mechanical structure holding them apart.
Mhm.
I didn't get that. What does that mean? I don't
That
understand.
means no diffraction spikes.
Oh, okay. Do you suppose what we see with gravitational lensing when there are not one, not two, but four different pictures around a galaxy that's closer to us, even though it's 9 billion light years away, the one behind it doesn't come off as a round circular, you know what I'm talking about?
It does if we discussed this before, Ron. It does if it's perfectly aligned.
Yeah.
Full Einstein ring.
It's
Yeah.
an alignment thing.
Yeah,
Yeah.
the image that it makes, it is a lens, but the image it makes is very, very distorted. And so you
Yes.
have to have a computer program to put the image back together, to undistort it from your estimates of the mass distribution in the lensing galaxy. If you were in a telescope workshop and did that, you would have made a very crappy lens. So,
Huh.
Another famous one, Ron, is the Einstein cross, where I think you're talking about that,
yeah,
where you see four images from one source.
Yeah.
Bending around the closer galaxy.
There's
There's also the
also,
Einstein ring, which is continuous.
There's a ring
all the way
too.
around.
yeah.
isn't the Einstein ring the same as the smiley face?
There is one that's an Einstein ring with other features in it that make it look like a smiley face. And
You
there's a
guys-
smiley face crater on Mars too.
Yeah.
But you guys can't focus in on that smiley face. It requires a web or
Oh.
something really,
Those are big time telescopes.
Yeah.
but they're out there.
Mm-hmm.
Diffraction spike patterns.
Yeah,
Well,
wave
okay.
nature of light, Ron. Wave nature of light.
I guess it is. You could do a whole program on light, I would imagine,
That was a really neat setup, Jerry. That was really neat.
fascinating. Well, we're gonna have a good talk from your old friend. You want to tell us briefly, how do you know Peter Love, Jerry? He's our guest speaker in a week and a half.
Peter and I were colleagues on various projects at making making detectors for infrared instruments at Santa Barbara Research Center.
Well, he's certainly the most.
For me, I was there about 35 years. And Peter was there quite a long time too. I don't remember exactly when he came, sometime in the 80s, I believe. He's a PhD in physics from UCSB, and I'm from UCLA. So
I guess he's never taught a class, but he does have that PhD, and he's certainly gung-ho, and he's a diehard member of the club.
when you work at places like Santa Barbara Research Center, you give a lot of talks and a lot of forums, and the line between teaching a class and these talks kind of blurs. So we do teach classes periodically. I taught some special topics classes at UCLA, and I think Peter did at several things like that at UCSB. I know a lot of other people did. I'd be surprised if Peter wasn't in that group.
Well, I taught classes at UCSB, and I didn't have to do anything except teach. I was just called a lecturer.
Yeah, that's
All right.
what we were too.
Well, I appreciate all the input, Chuck. You gave me Night Sky Network, and I'm trying to see if they can get me somebody for September, because I haven't heard back from NASA and JPL, but maybe they're last minute. I don't know. Gentlemen, we'll see you at the outreaches, with or without your beautiful wives. A lot of times they go, and we'll continue looking at the night sky. Was it a good closing down the other night? I think, Chuck, did it cloud over? Were you screwed up? 2 nights ago, you set a cancellation out.
Saturday night was supposed to be Refugio State Beach, and the cloud forecast was just grim, and it indeed was pretty bad. So we canceled on that.
Got to use the weather forecast.
Yeah.
Well, we'll see you in a week, and we'll do this again next Monday morning, and that'll be our 128th program. Gentlemen, take care of yourselves. Don't let them get to you.
Bye. Bye,
And
guys.
happy
And
speed.
I'll speak to Wikipedia about the Melody 111 and
The image, yeah.
Okay.
Give us a report next week. Thanks, Mr. President.